Okay, so in this problem, we're going to sketch the region enclosed by the curves, and we'll find its area. So let's start. I was already. Make sure my settings are good. Let's see. All right. So you should have these in y equals, right? I've already got them there, and I thought it was helpful to include the vertical line pi over 7 in here. Remember, that would have to be. You want to turn that off because we want to draw its inverse. We want x equals, not y equals. So I do have that in there, but I turned it off. So plug those in there, and then you may, as far as a window is concerned, this is the window I end up using. I just chose pi over 4, which is a little bit larger value than pi over 7, just to make sure I could see to the right if necessary. And then, again, before you graph, if you quit to the home screen, we can draw the inverse, so 8. Let's see, vars, y vars, function, and we chose cell 3, so y3. And if we draw its inverse, we get, decent picture of the graph there. So that vertical line is the graph, or is the equation x equals pi over 7. So as far as getting this area then, we know we're starting at 0. So we're going to find this area, right? And we're going to add it to this area. That's how we'll get the full area we need. And we need to split it up at this intersection point because remember, our theorem is only valid for our integrand. The first term of our integrand needs to be the function on top. And that switches there at that intersection point. So we're going to need to solve this equation here to get the intersection points that we need. So let's see, if you combine the cosine terms, you get 4 cosine of 7x equals 2, which means cosine of 7x needs to be a half, right? 2 over 4. Okay, and remember cosine, if we just set up a little right triangle here, or you can use the unit circle if you prefer. Cosine, this theta here is the argument of cosine, which is 7x, right? A cosine puts the adjacent side over the hypotenuse or the radius here. And that's using Pythagoreans, or maybe you already recognize this as a special triangle, pi over 3. There. That theta needs to be, which is 7x, that 7x needs to be the argument for cosine, cosine's a half. So that needs to be pi over 3. Right? Which means x itself is pi over 21. Now there is a negative value that would solve that, but remember cosine's positive in the first quadrant, right? And it's also positive in the negative quadrant, but we don't care about the negative side. That'll be this point because we're starting at 0. So we got that intersection point, and that is actually a smaller value than pi over 7, so that confirms, that's the intersection point, and that's another value we don't care about. So if we set up our intervals now, or our integrals, definite integrals that we need to actually get this region done, close this or group it so I can shrink it. We're going from, let's see, we got to go from, oops, that is not what I meant to do. Pen, no, I'll grab the green pen. We got to go from 0 to that pi over 21. And on that first region there, the function that's on top is the 2 cos, is that? Yeah, that's the 2 cosine 7x. And then we subtract out the other function, 2 minus 2 cosine 7x dx. And then we'll simplify this now. So we're going from 0 to pi over 21. And it turns out we've got, looks like 4 cosine 7x's. And that's just a minus 2 dx. All right, so that's one interval. And I'm just going to do a pause roll. So that's the first region. And then our other region, we're going to pick back up at pi over, I want that to be purple, pi over 21. And then we're going to go all the way to that vertical line pi over 7, where the interval stops. And on that region, the function in red, 2 minus 2 cosine 7x is the function that's on top. And we subtract out the 2 cosine 7x dx. So that region, pause this, I'll clean that up again. I just combine like terms to simplify that integrand. Okay, so that region needs to be added to the region we've up here, right? These two regions together will give us the total area that we're working with. So we got to work with both these integrals now. So luckily the terms are very similar. There may be even some potential, I guess not really symmetry. You could, if you did this, this is maybe in terms of y or something, but that won't be smart. Well, at least these terms are very similar, so the integration won't be too difficult. All right, so let's work with the cosine function. Let me get the antiderivative. So it is a u substitution, and ideally we'll do terms like this so often that ideally you'll see it and kind of memorize the process from there. But it is a u sub. U will be 7x, and then 1/7 of du is dx. You really always just end up dividing out whatever that coefficient is. So we're talking u is 7x, du is 1/7, or I should say dx is 1/7 of du. So basically we're going to have the 4, we've got to take care of that 1/7, and then it's going to be sine is the antiderivative of cosine, and we'll leave the 7x as it is. Then we got minus 2x, and we're going for that one, we're going from 0 to pi over 21. So let's see, if you plug that in, we've got sine, that'll end up being pi over 3. And remember, if we're talking pi over 3, that this is pi over 6. This is 1, 2, root 3. So sine puts the opposite. So we're talking root 3 opposite over the hypotenuse. So root 3 over 2. So this will be 4, let's write pi, 4 root 3. Right, because, yes, 4 root 3. And then root 3 over 2, so I really should have just done 2, because there's a 2 on bottom. So it's really just 2 over 7. 2 over 7 root 3. And then we got minus, this is going to be just 2 pi over 21. All right, so that is the first piece. I'll put that here. It's that piece there. And then we got to do the second half of the interval here. So, I guess I should erase this now. Maybe I'll leave that up. It'll just be another sine function, but I'll leave the right triangle up again. So for this bottom piece here, we're going to do, again, we got 2x, and we already said it's a u sub, right? But it's the same thing. So it's going to be minus 4/7 sine 7x. And then this time, we've got pi over 21, and we've got pi over 7. So, let's see, we've got 2 pi over 7, plug that in. And then here, the 7s are going to cancel, so you just got sine of pi, and sine of any integer multiple of pi is a 0, so that's just going to be a 0. When we plug in pi over 21, we're back to a sine of pi over 3 again. So there's the pi over 3. So we end up having, let's see, this is 4/7 times another root 3 over 2. So really that's just going to be minus 2/7 root 3. Right? There's 2 root 3 over 7, I should say. Is that right? Oh, you know what I'm missing? I've got to subtract these. Yeah. Okay. So that was my fault. No, not my fault. But if you didn't include, I should have put a 0 there basically to remind myself. So this goes in there, and we got the 2 pi over 7. And now when we go to subtract, we've got. You know what? Let me just start over. Something got lost in my head here. I don't know what happened. I know I asked it with that subtraction sign. I just got the sign wrong. All right, you plug this in, you get 2 pi over 7. And then this is the 0, whether you want to put that or not, it's up to you. Probably still shouldn't have put it, but there's the subtraction sign. And then we're plugging in, there's my 2 pi over 21. And then we already said this is going to be a minus 2 over 7 root 3. All right, so if we clean this up, we're going to get, let's see, this will be, if we make that 21, that's 3. So that's 6 minus 2 is 4 pi over 21. and then we end up getting a plus. There's my double minus, that's what I was concerned about. Plus 2 sevenths root 3. So this should be 4 pi over 21. Right, 4 pi over 21. Yep, and then plus 2 root 3 over 7. Okay, so remember the answer to this was adding them up. So if you add these up, this is the one region plus that one. Let's see, we've got, there's 2 root 3s over 7 plus another root 3 over 7 would be 3. Am I missing something again? Yes, I copied it down wrong. It's 2 sevenths root 3. I wrote root 3 over 7. 2 sevenths. So many root 3s we have. 2 root 3 over 7. Okay, so if we add this up, we've got 2 root 3 over 7 plus another 2 root 3 over 7 makes for 4 root 3 over 7. And then here we got to subtract out 2 from the 4 there, so it ends up being plus 2 pi over 21. And that should be the answer to that one. Okay, hopefully that helps. If you have any other questions, let me know. Thank you, bye.